All right, let's do the next example by hand now, okay, without any printed help. It doesn't, hopefully to mimic how you're going to do it on a quiz, a test, or whatever, okay? So we want to graph y equals 3 sine of 3x plus pi minus 1, okay? Let's follow this thought process. We're going to get the parameters, amplitude, period, those things. We're going to get the starting points. We're going to apply the quarter cycle and the max min, okay? And then we'll graph it. So let's first rewrite this in more of a standard form. Let's factor out this 3 to get the stretching factor out, or compressing factor. 3 sine of, if we factor out a 3, it'll be x plus pi over 3, and then minus 1. Okay, let's double check. If we distribute, we get 3x. Distribute to this, we get pi. Good. Okay. So let's get the parameters. What is the period? T is 2 pi over omega. Okay, and let's rewrite this as, in the other video, I wrote it as a sine of omega x minus v plus k, capital K, like that, okay? So the period is 2 pi over omega is 3 in this case. Okay, period is 2 pi over 3. And remember, the units are typically in seconds. I'm not going to write it here, though, because there's no unit given in this case, okay? That's period. Frequency, if you want to calculate, would be 1 over this. So let's write it. A lot of teachers require you to know this. It'll be 1 over 2 pi over 3, 1 over t, which is 3 over 2 pi. Units of this are typically hertz, or cycles per second, or 1 over seconds. So usually hertz is the most conventional way, okay? Now, how about amplitude? Amplitude is related to absolute value of capital A. Amplitude is 3. What about the midline, or the average value? It's the K. It's negative 1. Okay? And then what about phase shift? Phase shift is phi. It would be minus pi over 3. Okay. So, what do we do from here now? We want to get our starting points. So for the parent function sine of x, the starting point is when x is 0. So it will be 0, comma 0. Sine of 0 is 0. Okay? But there is a phase shift happening. So instead of 0, 0, we're going to cross the x coordinate out and replace it with this phase shift of minus pi over 3. That's going to be our new starting point. Okay? So let me write it a little better. Minus pi over 3, comma 0. Okay? This is our starting point. Okay? And actually, that's not exactly our starting point, because we can apply the midline as well. So let me first do it in terms of like how I did it in the last video. Let's do all the horizontal first, and then we'll worry about the vertical afterward, okay? So minus pi over 3 comma 0, okay? So then the next point would be a quarter cycle away. So let's do it on the side over here. Quarter cycle, a quarter period, is 2 pi over 3 times a fourth, which is, that would be pi over 6. Okay, so the next point would be minus pi over 3 plus pi over 6. And then for sine, quarter cycle away, it goes to the max. So it'll be 1. We didn't do anything, worrying about the y's later, remember? Okay. So this will be the next point. I'll simplify later. Next would be 2 quarter cycles away, or half a cycle. So that would be minus pi over 3 plus 2 times pi over 6, which is pi over 3. And then the next point, a quarter cycle away in the parent curve, so we started from mid, went up to the max, it goes back to the mid. That's how the sine works, okay? Next, be minus pi over 3 plus pi over 6 times 3. So it'll be pi over 2 then. This is 3 quarter cycles away. And then the next would be the min, so minus 1, okay? And lastly, now we are a full period away now. So it would be minus pi over 3 plus 2 pi over 3. That is just pi over 3, right? But let me write it. Plus 2 pi over 3. And then for the sine, the fifth point from the starting point, we're back to the mid. Okay? So let's simplify. This is minus pi over 3, comma 0. This is minus pi over 6, comma 2. This is 0, comma 0. This one is pi over 6, comma minus. I already applied the thing, so I'm reading from my sheet, that's why. I already calculated these out. Minus 1, and this is pi over 3, comma 0. Okay? So we got the x coordinates. Now let's get the y coordinate. So what is the range of this function? The range, let's write it out as well. It is, remember, it's midline plus or minus the amplitude. Minus 1 plus or minus 3. Okay? Which means it is from negative 4 to, because minus 1 minus 3, that's minus 4. Minus 1 plus 3, that is 2. This is the range in proper notation over there, okay? But how we calculate is negative 1 plus or minus 3. Midline plus or minus amplitude, okay? So, all the mids, we're going to change to minus 1. The maxes, we're going to change to 2. This is a mid, so minus 1. This is a min, so it becomes a minus 4. And then this is a mid, so it becomes a minus 1. Those are our 5 points right there. Okay? So I already have, since I already spoiled that, I already had a sheet with the things worked out. Here are the 5 points. Okay? And then we would just connect it. And then after that, after we connect those 5 points, we probably need another period. So how to do that? Well, you can take this point plus, at this point plus the period again, because this point plus the period is here. So you would get this point over there. This point plus the period, you get that point. This point plus the period, you get that point. Something like that, okay? All right, so that's how we go about transforming these trig functions. This, hopefully, once you start doing it, you'll see it's much easier than thinking about it in terms of stretching, compressing. But let's verify. Now that I said that, that's a good way to check our work. Okay? Or I guess if I graphed it correctly on the computer as well. Okay, so if we look here, there's a vertical stretch of 3 and there's a shift down by 1. Okay, so looks like it's right. There's for sure there's a shift down by 1 because the midline's at minus 1. And then we stretched it. Looks stretched because it's not going from plus or minus 1. Yeah, from the midline. Okay, and then I guess I have the equation here too. We also have a horizontal compression by 3. And the shift to the left, I'm flipping all my terms, by pi over 3. So originally, the period of sine of x was 0 to 2 pi, yeah? So from 0 to pi, it would have only been half the period, half the cycle. But look, there's already more than a cycle going on over here, yeah? It looks like 1.5 exactly, actually, okay? Now, yes, about that. And then there's a shift. This one's kind of hard to tell, but let's eyeball it. So this point used to be over here, and then it got shifted. So yeah, it looks about right. Okay, so that's how we can eyeball if we graphed it correctly via transformations, but don't use transformations to actually help you graph it. It's useful to help check your work in these cases, okay? All right, let's do another example. Y equals negative sine of 2x plus pi over 3 plus 0.5. Okay. So let's rewrite it in the standard form first. So let's factor out this 2 in the inside of the argument of the sign. So it'll be 2 times x plus pi over 6, like that, plus 0.5 on the outside still. Okay. Let's get our parameters. What's the period? It is 2 pi over 2, which is pi. Okay, so let's think about the transformations. There's a horizontal compression by 2, which makes sense because the original period is 2 pi, now the period is pi. So this is for sure compression. Okay, now phase shift. It is negative pi over 6. It's going to shift to the left by pi over 6, the starting point. Okay. Yeah, let's leave that there for now. We might have to adjust it in a bit. Spoiler alert. Okay, because of this guy. But let's do the amplitude first. What's the amplitude? It's absolute value of A. Remember, amplitude is always positive. So it is absolute value of -1, which is just 1. Okay. What's the midline? It is 0.5. Right there. Okay. Am I missing any parameter? This is a frequency. It's just 1 over pi. I'm not going to write that though, okay? We don't need that for the purpose of graphing. Okay. So there is a vertical reflection though. So either we handle that in addition, or if you remember, I forget if I said it in this video or the previous video, we can handle a vertical reflection by adding half a cycle to the phase. Half the period to the phase. Remember that? Where did I draw it? I should have the paper nearby. Let's see. Give me 1 second. Where did I put it? Right here. Remember this? Here's sine of x. Here's negative sine of x. This is just half the cycle away. So, with that, let's go back here. We can, instead of worrying about the reflection, let's lump it into the phase shift. So, plus half the period. The period is pi. So, plus pi over 2. So, the phase shift that we want to actually take into account is, if we simplify this, this is pi over 3. Okay? So, let's get our 5 points now. So, it would be pi over 3, comma, something, 4, 5, okay? Let's get the y's first, actually. The y is always easier, actually. So the range is 0.5 plus or minus 1. So that means it's going to go from minus 0.5 all the way up to 1.5, okay? So sine, it starts at the mid. So this is going to be 0.5. It goes up to the max at a quarter cycle later, so 1.5. Goes back to the mid, goes to the min, and then goes back to the mid. Okay, this is how we quickly get the y's. Now for the x's, we keep adding quarter cycle to each of the x's here. Okay, so we start from pi over 3, add a quarter cycle, so plus pi over 4. If I do the math, it is 7 pi over 12. Okay, I already have this down. So if we add another pi over 4 to here, that would be 5 pi over 6. If I add another pi over 4 here, that would be 13 pi over 12. Okay, and then if I add another pi over 4 here, that would be 4 pi over 3. We got our 5 points. Much quicker, hopefully. You're now convinced. Okay, And if we graph it, right here. And then just do additional period on either side. All right, let's quickly check. There's a vertical reflection for this from sine of x. That right? Looks like it is. Like toward here, it shifted, didn't shift that much horizontally. So over here, instead of going upward, something like that, it's going downward. So it looks like the reflection happened. And again, we took it into account via the phase shift instead, so that we didn't have to worry about it. Okay. Shift up by 0.5. Looks like it did, right? It got compressed. So original period 0 to 2 pi. Looks like there's more than one period already happening, right? And then it got shifted to the left by pi over 6. So the mid is over here and then reflected, yeah? So that's why. Looks about right. Okay, that'll be it for this video. In the next video, I will do one where we apply even and odd function properties.